Two-dimensional shapes are called plane geometry. Polygons are plane shapes entirely bound by straight lines. Diagrams are often used to teach these shapes in terms of their invariance, symmetry, and transformations. Because of the abstract natures of diagrams represent, and its reliance on individuals' ability to see and visualize the relationships, additional tools are often needed to help children comprehend the concepts. We will look at 4 materials that can be used to teach polygons in this session. Tangrams are 7 pieces puzzles that originated from China. It comes with 2 large triangles, 1 medium-sized triangle, 2 smaller triangles, 1 square, and 1 parallelogram. They are useful to help children understand see shapes from different perspectives, and they join shapes together. For example, I have got a square joined by 2 large triangles, or a similar square joined by 2 smaller triangles. They can help children understand that shapes are formed by combinations of shapes. So for example, I've got one made here, 2 pieces formed by a large triangles, or I can have one with 3 pieces joined together, 1 square, 2 smaller triangles, or 2 smaller triangles with 1 parallelogram, or I can have a similar shapes made together but rotated in a different way. So if I turn it this way, you can see that they are the same. However good that this material is, there is one limitation. When it comes to making triangles, the only triangles it can make is an isosceles right-angle triangles. It can't make any other types of triangles. To understand triangles in all its entirety, we need a different material. Geoboard is a great tool to help children understand the properties of two-dimensional shapes in terms of its side length and corner. So for example, I've made a rectangles by joining 3 pegs across, 4 pegs below. Notice 3 across, 4 below, 3, 4 does not make 12. It makes 6 square. And that's something teachers need to pay attention. You can also use a Geoboard app to get children to make shapes of different kinds. To do that, what they need to do is to drag a rubber band and join them together. I can create many different kinds of triangles in this case that I can't do when I use a tangram. So for example, I've got a right angle isosceles triangles, a right angle triangle, isosceles triangle, or a scaling. However, I have here a triangles. At one glance, it looks like an equilateral triangles. But is it really one? Let's have a look. If I join that together, if I compare the side length from here to here, I know that that's the same. That's the same. But if I point this together, I know that there is a gap here. So while Geoboard is great, it cannot make an equilateral triangle. Papers are readily available, and it can be used as a great tool to help children understand two-dimensional shapes. So in this instance, I get children to fold 3 similar trapezium. How do I know they are similar? I compare the angles and the side lengths together. So in this case, I know that they are all similar but different in magnitude, because each of the corners are exactly the same, and the only thing differ is their side length, and the side length changes in proportions. I can also fold regular shapes. What is regular? Regular is the term used in geometry to refer to a shape where all its angles are the same magnitude and all the side lengths are the same. In this case, I can easily get children superimpose the corners together. So I know this corner and this corner is the same. This corner and this corner is the same. This corner and this corner is the same. That's what we call informal reasoning, helping children to understand they are equilateral because all the side length and all the corner are exactly the same size. Another great tool that you can use to teach two-dimensional shapes is end legs. End legs are strips of plastics that comes in different colors and different sizes. You can use that to get children to make similar shapes. In this case, I've got a similar equilateral triangles. You can also get children to compare shapes of the same family. So for example, I have here a isosceles triangles. In actual fact, I've made 3. Notice that the base are the same length, but the sides are not. And the sides determine the dimensions of the magnitude of the corners. So in this case, I have one that says 40 here. This one, it's about 35. Now, is this going to be bigger than this or smaller than this one? We can superimpose to compare. We can tell that this one has the largest corner. So what it tells you is that the side length of a triangle has a direct impact on the magnitude of the shapes, and children can investigate that. The other thing good about using end legs is when it comes to quadrilateral, I can get children to understand what we call the dynamic of changing shapes. Here I have a triangle made of 2 yellow colors and 2 orange strips. If I tilt it, I've just made myself a kite, and I can just change the size of the kite. What happens if I push it upward? I just make myself a chevron. No matter how good a end leg is, one of the difficulties it has is it can't help children understand that shapes can be made by combination of shapes. To do this, you have to use the tangram.